Hello, everyone. Welcome to today's webinar entitled, it's titled Enhanced Performance Insulation Systems for Adhered Masonry Veneer. I'm Jim Olson with the National Tile Contractors Association. I want to welcome you and thank you for taking time out of your day today to be here for this webinar that is sponsored by Laticrete International. Before I introduce today's speaker, I want to remind you that during the webinar, you will be muted. Please use the questions area on your computer to type in your questions. We will answer them at the end of this program. If the audio on your computer is poor, call the number on the invite to this webinar and listen on your phone. All NTCA webinars are available to watch at any time on the NTCA YouTube channel shortly after the webinars are presented. Within 72 hours, it'll be up on our YouTube channel. And this should give you easier access to watch and share all current and past programs at your convenience. All right, here we go. I'm really excited to introduce today's speaker, Daniel B. Rothberg. He graduated in 2012 from the Colorado College with a Bachelor's of Art in Geology with distinction and a minor in Asian Studies. After graduating from college, he worked as an instructor for the National Outdoor Leadership School based out of Lander, Wyoming, taking youth adults into the wilderness on month-long expeditions, teaching both hard and soft skills. Feeling the call of the grout, he moved to Monterrey, Mexico to begin working with Laticrete Mexicana. What was to be a short stint as an intern morphed into a longer-term position. Daniel took a lead role in introducing and developing newly acquired product lines in the Mexican market. Daniel continued working with the international team based out of the United States, USA, as the regional manager for Laticrete's flooring division in Latin America. He was heavily involved with the acquisition of Solapoxy Revestimentos in Sao Paulo, Brazil, based manufacturer of resinous flooring materials. He traveled extensively from Mexico to Chile, helping the Laticrete team find success with their new high-performance flooring solutions line. In 2020, Daniel decided to change course and pursued an accelerated MBA at the University of Oregon, where he graduated in the top 20% of his class. Daniel now works in the global headquarters in Bethany, Connecticut, as product manager for Laticrete's masonry, veneer installation system, as well as 3D printing. Excited to hear about that in the future. So that sounds great. Daniel, welcome. We look forward to your presentation.
Thank you so much, Jim. It's a pleasure to be here with you all. So welcome to the webinar on enhanced performance installation systems for thin adhered masonry veneer. Let's do it. Let's see if my clicker will work. All right, cool. So bit of an agenda. What we're going to talk about today is starting with the traditional method for installation of thin veneer. We're going to look at the wall constructs associated with that, and then go into some of the issues associated with this traditional method. After that, we'll look at a more modern engineered method of adhered veneer installations and the wall constructs associated with that, followed by some of the specific tests, standards, and codes around this, as well as some of the benefits, the cost, speed, efficiencies, and other benefits that you get using this newer methodology, and just some job highlights, and finish off with some resources. All right, thick or thin, which is better? So before getting into the which type is better, I want to sort of level set about what is thin adhered masonry veneer. So, thin masonry veneer is a relatively new development born out of full dimension masonry. So we all know what masonry is. It's one of the oldest and most enduring wall and building constructs, building with stone and brick. So thin masonry is sort of a way to mimic the look of full masonry, but it's actually just a thin veneer instead of a full stone or a full brick. It's a thin slice of brick or a thin slice of stone Or these days, what's becoming increasingly popular is manufactured stone, made in a mold to look like stone, but it's thin. You know, these are quite different in that the full masonry is actually a self-supporting structural member. You know, you're building a structural part of the building, and it's built, it's stacked on top of itself, and the weight, it's supporting itself, and the weight goes down onto the foundation. Whereas thin veneer is actually, it's not a structural component, it's an adhered facade. It's a decorative component adhered to a structural part of the building. So they can look similar, but they're quite different in terms of how they're constructed and sort of the functionality of them. And okay, which is better? You know, sort of a trick question. One is not necessarily better than the other. It depends on what the purpose, what are you looking for out of it? Like I said, a full masonry of stone wall, you know, if you're building a courthouse or a university, something you want to last hundreds of years, full masonry still is really the most durable type of building construction out there. Advantages of the thin masonry, you know, the design flexibility is very high. If you're thinking you might want to remodel, you don't have to tear down the entire wall. You can do it by section. You know, and then there's some other benefits in terms of efficiencies during the installation that we'll touch on later. All right, so the lath and scratch method is the traditional method of installing masonry veneer. And you know, it's called masonry veneer because, like I just explained, it's born out of full masonry. And because of that, it has gone to a masonry part of architectural specifications. It's gone to Division 4, whereas tiles in Division 9. And it's gone to the masons and to the masonry distribution because it comes from that world. And so really historically, the installation method comes from masonry materials and masonry methods. And that's why we're still working with this lath scratch and a lot of traditional materials. So before we get into like the actual lath scratch, the installation of the veneer itself, it's really important to understand how the walls, the full wall system is constructed, because it's all an important piece of the puzzle, right? So in North America, United States and Canada, 80% of our buildings are made with some type of frame construction, be it wood frame or steel frame. And then the walls, you know, between that frame, you have sheathing, either wood sheathing or mostly gypsum-based sheathing. So on the left in this photo here, you can see a wood frame and a oriented strand board sheathing, and on the right is going to be a steel frame and the gypsum exterior rated sheathing. So typically you'll see the wood in the residential part of the market and the gypsum board and the steel in the commercial part of the market. And that division generally is based on the different code requirements specifically around fire for those different markets, with steel and gypsum obviously being more resistant to fire. So after you get your sheathing out, the next step is to get a building, a WRB, a weather resistant barrier or an air barrier. And there's many different types of air barriers or WRBs on the market. What I'm showing you here are two of the most commonly used WRBs. On the left, you can see the 15-pound builder's felt. And on the right is, you know, a plastic type of building wrap, like a Tyvek. There's a number of other types of WRBs and air barriers, like there's peel and sticks. One that's gaining popularity these days is liquid applied air barrier membranes. So there's a number of different types, and the trades that install it, it's actually quite varied in terms of who's going to be the trade that installs this part of the building. Oftentimes it's really dictated by the finish that's going over the wrap. So if it's stucco versus siding versus masonry, you know, you can get masons installing it, you can get the stucco guys installing it. It can even be painters or waterproofers. So once you get that wrap up, the next step, now we're getting into the meat of the masonry veneer installation of the traditional method with the installation of the metal lath. So this is self-furring galvanized diamond mesh lath. It usually weighs between 5 and 6 pounds for a 2 by 8 foot sheet. And on the right side, on the right-hand photo there, you can see the parallel horizontal V grooves there. That's the self-furring part. So it's a 1/4 inch groove, and what that does is it holds the lath off of the wall by a 1/4 of an inch, and that allows you, as you get that scratch coat embedded in there, that 1/4 inch gap allows the mortar to fall behind, because code dictates for a scratch coat, you need a 1/2 inch total thickness. So you get a 1/4 behind, a 1/4 in front. So a couple things to note, you need to overlap that lath by 1 to 2 inches between sheets. On the left-hand photo, you can see that's an example of an improperly joined sheet. There's no overlap. That essentially creates a movement joint and allows a lot of flexion, a lot of movement to happen between the sheets there, and you can get crack propagation. Something that we're going to come back to quite a few times in this presentation is the fact that to actually adhere this lath to the wall, you mechanically fix it, right? You got nails and you got staples through your WRB into the sheathing and into the studs in your frame, and it's a little bit counterproductive, right? Because you're putting tons of holes in something that's supposed to be waterproof. And another possible issue that we'll talk about is the fact that although these sheets are galvanized, the edges of them, due to the shaping process, can lack in protection, and so you can get rust there. So that 80% of buildings in North America being framed, the remaining 20%, depending on where you live in the United States, you can get a lot of concrete CMU construction, and you still need a metal lath to attach to the concrete to build out your scratch coat and to build out your adhered veneer system. The traditional mortars that are used by most masons, being type S or type N mortars, they're really meant for traditional masonry, for stacking bricks and stacking blocks. They don't have much, if any, actual chemical adhesion, and so they're not meant to stick to walls. Even though it's a concrete or a CMU block wall, you still need that mechanical anchoring that you get with the lath. So you still need that lath put up. Next step, you gotta get your mortar going. So the pictures you see here are, the very traditional method, the site mixed. You got a pile of sand, a pile of cement, water, and a mixer, and you mix up your own mortar, and that has obvious risks in that you're introducing a lot of inconsistency and a lot of variability throughout the day. Imagine you're shoveling, you're getting tired. Are you really going to be able to keep that water to sand to cement ratio consistent? If it's a humid day out, sand and cement is going to absorb moisture and change the consistency. You're seeing less of this these days and more of a pre-bagged, factory blended type S mortars come in an 80-pound bag. So once you get that mixed up, the traditional way to do it is you got a table with a big bunch of mortar, and then you put it onto your hawk. That tray-like tool that the guy on the left is using is called a hawk and trowel, and you parge it from the bottom up. And like I said, you got to get it 1/2 inch thick. So you got to really push it in, make sure you're getting a 1/4 inch behind it. And then you have to wait a full 24 hours before you can do any additional lifts or go onto your adhesion, your bond coat. So the next step, well, I should mention that you need to then scratch. The scratch and the scratch coat refers to the mechanical form. You can see on the right that those parallel grooves, because your adhesion coat, your bond coat, is still an unmodified type S mortar, it needs a mechanical bond. So you have to scratch it, and you're supposed to do it horizontally. You can see the guy on the left, sometimes they tend to do it in just random scratches, and that's a little bit risky in that it can introduce air behind the system. So yeah, and on the right side, you can see another issue there. What this guy's doing is he's pointing and setting at the same time, and what code standards dictate is that you wait 24 hours after setting your stone to allow the excess moisture to leave the system. because you want that pointing mortar in the joint. If you get a lot of moisture coming out through it, there can be inconsistencies in color and performance. So this is what you'll most commonly see in terms of the traditional masonry method of adhering the veneer. You know, it's type S mortar, requires a 1/2 inch thick bed to hydrate properly. So you got to do a huge glob on the back of that unit. And they'll often do a donut style back butter because since the mortar doesn't have much adhesion, it works via mechanical grabbing, and there's also some suction involved. It's not quote unquote suction, but making that donut can create this void that increases the suction, but it also decreases coverage, and it can introduce an air pocket, which can really facilitate freeze thaw action and creates a lot of issues further on down the road with pop-offs. So after you get stuff adhered, you have to point. You can use the same sand cement unmodified mortar, what they do traditionally. On the left is called tuck pointing with the trowel. On the right, you can use a grout bag. And then after it's thumbprint hard, you come back with a tool and you tool it, make it look nice. All right, so this is the typical construct that you see, what we just talked about, the 2 layers of WRB, galvanized lath, and the scratch coat. You know, some of the issues with that, like we said, you're penetrating your waterproof barrier with tons of nails and tons of staples, right? So is it really waterproof? I'm not sure about that. There's tests for nail sealability, ASTM D1970. There are certain types of products that can seal in a water and airtight fashion around nails. The builder's felt's not one of those. It's typically the liquid applied air barriers tend to pass the ASTM D1970 nail sealability. So it's okay with certain products, other ones it's a little more challenging. So another and possibly more risky issue is the fact that you have this metal lath outboard of your waterproofing and inboard of your highly porous sand and cement mortar, which acts like a sponge. It's you know, through capillary action, sucks in a lot of moisture, and then with your water barrier behind, it holds moisture against that metal, right? So the obvious danger there is you end up getting a lot of rust, and once that lath starts to rust, it can just propagate and can present some issues. So some of those issues are, right, pop-offs. Like on the left, you can see this veneer unit had full coverage, but again, these type S, type N mortars are lacking in adhesive strength. They're lacking in shear bond strength, and they just don't have a great grab on that wall. So similarly on the right, it's a pop-off and likely induced by the fact that you have the veneer coming right down to the soil. Soil has a lot of moisture. This is a concrete construction, so it's going to pull all that moisture up and induce a lot of freeze thaw into that situation. And this is a stacked stone job where the stone veneer is sitting on each other. So once the first layer goes, the second layer loses its support, introduce more stress, that layer pops off, and you can get a cascade of failure. All right, here's a couple other similar but related issues. On the left, this is a wood-framed construction, multi 2 or 3 story hotel. One conspicuous thing you'll notice, and the tile guys are more used to it, but in the masonry side, it's not so common. There's no joints. There's no movement or expansion joints in this facade, right? It's a wood frame. There's going to be a lot of movement. You can see that buckling in that scratch coat between the layers. That's evidence of movement from compressive stresses. And so you get a pop off due to that movement. Then you get water intrusion, the lath rusts, and the whole problem just cascades. On the right, what you see is the entire delamination of that column of adhered veneer, mostly due to the fact that they tried to stick all these pieces using a sand cement unmodified mortar straight to a concrete wall without a scratch coat. And like we mentioned, it really doesn't have those adhesive properties. So once you start to get a little movement, you know, a train goes by, the building settles, whatever, the stone's not going to hold on. So this one on the left is an interesting one where they did use a lath, but they skipped the scratch and thought that they could go straight from the bond coat straight onto the lath. So they back buttered that thin brick and stuck it to the lath. And essentially you don't have a full scratch coat. You're missing, you just have a void in the wall there. There's a lot of movement. It's not a proper assembly. On the right there is what they call the two-bob glob method, where you know, you just put a glob of mortar on the back of the veneer unit, stick it to the wall. So it works in the moment, it's fast, it's nice, but you don't get full coverage. And over time, that lack of coverage exposes the scratch coat to moisture-laden air, which then can start to rust the lath. The rust propagates, same story. So this is an interesting test demonstration that we conducted with a properly made lath and scratch coat cured for a month, and then we adhered the veneer unit to that scratch coat. You can see the darker mortar is our mortar. We waited 24 hours only and then did a pull test. We just wanted to see where was the weak link. And obviously the weak link is that the lath itself, you know, where it creates that plane of the lath is a weakness, and it shears right off. All right, so what did we do about this? And what is the industry doing about this? You know, it's only the veneer, thin veneer finish type is only a couple decades old at most. And so you're now really starting to see a lot more issues as time passes and the use of this veneer increases. So now a lot of these issues are coming to the forefront. So what are people doing about this is introducing chemistry into the mix. And so, you know, you guys are probably relatively familiar with Laticrete from the tile side. So this is what we did to the tile industry 60 years ago. You may remember even 40, 30 years ago, showers were installed. If you wanted to install tile on the inside of your shower, you would use an unmodified mortar on a metal lath, no waterproof barrier, and that's how it used to be done. But you wouldn't dream of doing that today, because we now know that there's a superior way of doing that. You introduce polymer modified mortars, you introduce moisture and waterproof barriers. And so essentially what we're doing here is we're taking the technology that we've perfected over 6 decades in the tile industry and moving that over to the exterior facade world and to the Division 4 masonry world. You know, it's not only the chemistry of the product itself that we've introduced into the masonry world. It's this concept of an engineered system, a warranted system, where products are developed in concert to work together to provide the best solution to an application. So with the shower example, right, the critical piece there is this air and water barrier membrane that is designed to bond to the substrate and bond to the adhesive mortar, and it simultaneously protects the interior of the building and the interior of the wall from the penetration of moisture-laden air and water. At the same time, it protects the finish material, the veneer, from the excess movement in the structure, right? It's a crack isolation membrane, so it helps prevent cracks from propagating into the finish. As far as the product itself, the mortar, the adhesive mortars, you know, our mortars are 6 times stronger. Our weakest mortar is 6 times stronger than what the masonry code ASTM C270 mandates at 50 psi shear bond. So it really is able to, you know, withstand the stresses on the outside of a building are tremendous, right? You get freeze thaw, you get a lot of movement, you got the sun expanding, contracting, so you need to have a highly engineered product to support all those stresses, and also to be able to withstand poor workmanship. You know, our mortars are easier to use, and they are able to sort of look past poor workmanship and perform their job regardless of the training of the user. They're extremely non-sag, where a traditional type S or site mix sand and cement mortar, you know, you have to start from the bottom and go up. You need ledgers. You can't adjust once with a traditional unmodified mortar, since it uses that suction effect. Once you stick it to the wall, it's in the spot it's going to be. You can't adjust it. It'll just fall off. It'll break that seal. With an engineered modified mortar, you can adjust it as much as you want. You can install it from the top down. So it really allows tremendous flexibility of installation. Additionally, you know, although the bag may be more expensive, it goes much further, right? The coverage is much higher because, like we said before, the Type S traditional mortar require at least a 1/2 inch thick bed. You guys know it's like thin set. You know, you take a 1/2 by 1/2 notch trowel, you trowel it out, you get a 1/4 inch. You can even go, you know, to thinner than a 1/4 of an inch, and so the mortar, it goes much farther. All right, so with these new products, you can create engineered systems. So what we're looking at here on the left is sort of our preferred system, which uses cement board. You guys are, I imagine, very familiar with cement board. So in this case, the cement board essentially replaces that lath scratch, because what the lath scratch is doing is it's creating a bondable substrate. The cement board is doing the same thing, except it comes from a factory. So it's much more highly quality controlled. Using cement board lends a lot of productivity. You know, it's much faster to screw up some board than it is to mix up mortar, nail lath, and then install mortar, and then wait 24 hours. So you don't have to wait. Once you screw up the board, you can continue with your installation system. Additionally, what you can notice in this detail here on the left is that there's no, using the cement board negates the need for a WRB, weather resistant barrier, over the sheathing. When you use a lath and scratch coat, 2 WRBs are required. One of those is considered a sacrificial layer. When you apply a wet mortar against it, it's considered sacrificial. In this case, when you use cement board, you only need 1 air barrier. And in our Laticrete MVIS system, that air barrier gets moved outboard because it's a bonded part of that system. So it goes sheathing, cement board, air and water barrier, veneer mortar, and then your finish. The interior system is quite similar, except you don't need the sheathing, just because there's a little bit less movement and a little bit less risk on the interior side. All right, so that's our preferred method, is to use cement board. You can indeed use an engineered Laticrete or other fully warranted system with a lath and scratch method. That layer E there is the scratch coat. We have an engineered mortar that performs as a scratch coat. What you'll notice here is that layer G is an additional layer compared to when you use cement board. Like I said, you need that sacrificial WRB, so that's a 15-pound builder's felt there. Lath scratch, air and water barrier, veneer mortar, and finish. And importantly, when you move that layer D, that air and water barrier, outboard, so if you remember in the traditional system, your only water protection is that layer G. You would have 2 layers of G behind the lath, right? So you're allowing the water to come in contact with that lath and rust it. In this situation, you're moving the water protection further out, and so you're protecting that lath and you're protecting the structure behind it. All right, now we're seeing a lot of changes in wall assembly construction. In addition to the way that the thin veneer is adhered, you're also seeing additional layers inboard of the veneer. You know, for different reasons and in different climate zones, we have a lot of focus about water damage, and we have a lot of focus on energy efficiency. So with this, the detail on the left is an adhered veneer system, cement board adhered veneer system with the inclusion of a drainage plane or a rain screen. So, you know, years ago there was an issue with in the EIFS world where they had water got into the system and it caused massive failures. So we're really concerned about water penetration. So how this works is it provides a 1/4 inch or 10 millimeter gap, air gap for, in Canada, 10 millimeters, in the US, a 1/4 inch, and it allows any moisture that does penetrate through the system, through the veneer and through the cement board, is allowed to drain and dry in that airspace, and it doesn't cause issues. On the right-hand side, you have that layer of continuous insulation. So this is becoming more common, especially in northern climates, to have 2, 3, or up inches of polyiso, XPS, or EPS insulation, you know, outboard of the structure. You know, traditional insulation is batten insulation between the framing members, which isn't the best because those steel, particularly steel studs, they conduct heat very well, and they provide thermal bridging. So if you want to increase your insulation and your efficiency, you need to bring that rigid insulation outboard. And in a lot of cases, you see both rigid continuous insulation and a drainage plane. So it's quite a complex, thick system, right? So you have, in this case, you have your sheathing, your air barrier, drainage, continuous insulation, cement board, a water, bulk water, crack isolation membrane, then your adhesive and your finish. So one distinction that you'll notice with these more complex, thicker systems is you'll actually have 2 layers of fluid applied air barriers. So you know, in what we call the simple system, which we showed before, our preferred system over cement board, we brought that air and water barrier outboards, right, to protect the interior. And it's an air barrier because you're able to tie it all in to make a monolithic barrier. So that gets a little bit tricky with the penetrations, right? Window sills, door jambs, pipe penetrations. You have to tie it in using flashing. Which we can do. It just, once you add 2 or 3 inches of continuous insulation, a 1/4 inch of a rain screen, you're bringing everything much further outboard. It becomes much more difficult to tie the outboard air barrier in. So what architects do is they create a redundant system. So you have an air barrier on the sheathing, and then you have a crack isolation membrane on the cement board. So the air barrier on the sheathing protects the interior wall from air, moisture, and water penetration, and the water and crack isolation protects that the insulation and the middle part of that wall assembly from bulk water from getting in, at the same time as that it protects the finish from cracking. All right, so we've been talking a big game about this whole engineered adhered veneer system versus the traditional site mix sand cement, but can we walk the walk? So here's a pretty interesting use case. This is a picture of a mall, I believe it is, or a department store in California from the 70s. There was a huge earthquake in 1994. The whole thing collapsed, and what remains standing is the veneer, the facade, stuck to the substrate. You can see cracks going through the tile. You can see the veneer wrapping around those bends, and that's only possible thanks to you know, engineered modified mortars. If that was an unmodified traditional mortar, it would have been rubble. All right, getting into a little bit of testing. You know, we said there's a lot of similarities, at least in the chemistry, between tile installation systems and masonry veneer installation systems. What is quite different is the testing and code requirements for exterior facades. So probably arguably the most important one is this NFPA 285 fire assembly test. It's quite rigorous. It's very common in the industry, and you're not going to go on commercial jobs unless you can pass it. So Miami-Dade hurricane testing, you know, like it's Miami-Dade County in Florida, a lot of hurricanes, right? So they developed the standard. It's applied in a lot of hurricane zones. It's kind of neat. It's actually a ballistic test where they shoot flying objects at a wall and it has to withstand cracking. So that's becoming pretty common. And one thing that's interesting about these tests is they are assembly tests. So it's specific to a full wall assembly, not just a Laticrete product or a manufactured stone product. It has to test the entire assembly. So there's a little bit of complexity in terms of, obviously you're not going to have all of the permutations of every assembly. So engineers are used to switch out products, for example, based on these tests, which are specific to how individual products burn. So the engineers can take the values from this test and stick it into a computer program and see if it would pass an NFPA 285 assembly that somebody else did, because you can't test every possible assembly. All right, so building codes in the commercial world in particular for exterior facades are critical. And for thin adhered veneer, the regulating body is what's called the Masonry Society, the TMS. They write the code for all of masonry, you know, the bulk of which is brick and block walls, but they do have a section, I believe it's section 12, on adhered veneer. Okay, and so previously what the regulation, the standard for the mortar used as a bond coat to adhere veneer was that it had to comply with the ASTM C270 shear bond strength of 50 PSI. This summer, there's a vote going out in the TMS, which is likely to pass, which is going to mandate an ANSI 118.4 adhesive mortar to be used in the bond coat for thin adhered veneer masonry. That'll take a couple of years to become effective. And then the International Building Code sort of defers to the TMS on masonry affairs. And so once the TMS approves this, the IBC will adopt it, and then it slowly and disparately will trickle down to states and municipal codes. So it's not like it's going to be a light switch from day to night, but things are changing, and the methods and the products in the adhered veneer world are going to change. All right, talking about some of the efficiencies and the savings, you know, you can talk about thick to thin, right? Like I said in the beginning, full dimension masonry is a structural, self-supporting wall, so you have to build out a brick ledge. The bigger the wall is, the bigger the brick ledge. That's space, right? So, you know, thin veneer relative to this will save space and add more interior space. Additionally, if you have to, you know, if it's a multi-story full brick veneer or masonry veneer, you need these lintels, which are essentially brick ledges on other floors. You know, those are costly to install. You have to bring a welder in. That's more time. That's more money. Here you can see the black circle is the attachment, and the red is the space that you save. So there are design efficiencies from going thick to thin. And then within thin, if you compare the traditional methodology to sort of the Laticrete methodology, you know, we wanted to put our money where our mouth is. So we did this really cool test where we used this third-party laboratory where they actually built 2 mock-up houses, and in a controlled, you know, controlling the variables. So the same finish material, they use the same crew to install using the traditional method and install using a cement board, an engineered method, and they filmed it and timed every step. So we we're able to get an unbiased study on how much faster this newer methodology is, and each step of the way how long it takes. So from that, we developed this really cool cost savings calculator, which takes those times, and then we added a bunch of stuff, right? Like how big is your area? What type of construction is it? What's the labor rate in your area? And plugged it in and made this calculator that will outline every step in the wall assembly. We suggest material prices, but we allow you to input different material prices because those change by geography and through time. We allow you to choose a non-warranted system if you want to go apples to apples, or a warranted system. The difference is that with the warranted system, you add that air and water barrier membrane, right? And you get that protection, that extra protection. And then you can calculate your savings. So what we're looking at here is, a frame construction, apples to apples, non-warranted system with a $45 per hour labor rate. And you can see you get almost 30% savings. Now, if you want a warranty, a 15 or 25-year warranty, you get you add that membrane. The break-even point, it depends on the labor, because since the cost savings come from the labor, a lot of the cost savings come from the labor, the break-even point is $55 per hour. Above $55 or 50 or 55, even with a warranty, our system is more cost effective. And then if it's a concrete substrate, it becomes, the savings are even greater, right? Because you eliminate a lot of the stuff behind the adhered veneer layer. You eliminate the cement board or the last scratch, and you can go directly to the concrete with, it's precast concrete, air water barrier veneer mortar, and then your finish. And, the break-even labor cost there is something like $18 or $20 per hour, which is lower than really what you'll find these days. All right, so just showing off a couple cool projects that we've done to show you what you can do with this kind of stuff. This is the War Memorial in Richmond, Virginia. Pretty sure it's like all the wars is the memorial since World War II. A really nice large format dimensional stone was used here. Here's another neat one from Baton Rouge. It's a pretty fancy law office that used some nice thin stone with got a helicopter on top just in case. This one I'm pretty psyched on. This is a really neat job in Tampa, Florida, where they needed a district water cooling facility. So what it is it's a concrete on the bottom, concrete construction, then it's a 33-foot tall screen wall, which actually conceals all these chiller turbines that send cold water out to the different buildings, and it like centralizes the cooling. But it was a very difficult engineering task because it's just the screen wall is bigger than the structural building itself, so you have a lot of movement. You can actually see they did put expansion joints in here, but a lot of movement, a lot of thermal stress because it's in Florida. So they went with a Laticrete MVis system. There's actually go on our YouTube, there's a cool video on it now. All right, so to bring it home a bit, adhered thin veneer is growing steadily as a chosen finish type. Although the traditional masonry method, if properly constructed, is effective, there are risks associated with it, and there's now enhanced, engineered, higher performance installation methods, which offer higher value. These systems offer additional assurances of quality, like manufacturer's warranties. And, over time, we think that given the codes and given how things are going, likely the adhered, engineered method of installation will slowly but steadily replace the older methods. All right, that's pretty much the end of the show here. I just wanted to end with a couple of resources for you guys. So you're probably familiar with the TCNA handbook for tile. This is the MVMA installation guide for thin veneer. It's essentially the masonry counterpart to the TCNA handbook. and it has everything you could possibly need to know, you know, from standards, codes, the correct materials, the correct installation procedures, all the different architectural details. So it really is a super helpful document. And then here are some of the more important organizations and associations within the masonry industry that can also help you out. Aside from the MVMA, there's the NCMA and the BIA. So yeah, thank you guys so much for attending. That's the end of the presentation.
Daniel, great job. Appreciate all the information that you gave, and I like the options that you presented out there. We do have a couple of questions that came in, and I know that you have Robert Duke that's going to help answer maybe some questions if necessary, and he'll chime in. So I'm just going to start asking them. So as a masonry contractor, are you held to the ANSI A108.5 to achieve minimum 95% contact and coverage?
In general, I believe, and I'm going to ask Bob to chime in for a more official voice, but we recommend 100% coverage. So, Bob, I don't know, you can speak to that, the ANSI 118.
That is correct. That is correct. 100% coverage. The adhered veneers side of the business requires 100%. They looked at maybe changing that down the road, but they haven't done that yet because you know how things go. Sometimes if you take it to 95, you might get 90. So they want to say 100, and that way we try to achieve that best possible.
Great. Excellent. Thank you. Let's see what else we have here. Do impervious materials require chemical bond?
I assume you're referring here to a liquid applied air and water barrier membrane, which is a latex based membrane. Yeah, so how that sticks onto the substrate is primarily a chemical bond.
Greg Moat, if that doesn't answer your question, will you please add to your question? Thank you. All right. We've got a couple excellent programs, great info, but at this point, you guys did such a great job that we don't have a lot of questions now. I think people are taking in all that information and trying to think how they can add this to their repertoire. So thank you, Daniel. Thank you, Bob. I appreciate your time. Everybody, oh, here we got a question come in. Got one right now. Is a weep system needed in these setups?
Bob, go ahead.
Depending on the system, if you're using what we call the simple system that Daniel was talking about, where it's sheathing backer board with the air and water barrier outboard, that is not a weep type system. But when you start getting into the drainage plane with continuous installation and things of that nature, those are still weep systems. So those would be required to, you know, put your weep in the correct and tie that in as well. So there's a couple of different systems we can help out with. If you have a system out there that you're working on, you can let us know. We can help you design that or work with you in the design.
So I know that all manufacturers of a set of material have a great technical line, a technical, you know, hotline or whatever that people can call. And I guess I would recommend anyone doing one of these systems would feel comfortable calling Laticrete and talking to them about the options, right? And what the right way and wrong way and how you recommend going before it. So always important to check with your manufacturer. They'll be there for you. They'll help you do it the right way and get through any obstacles. That's great. Okay. I guess I don't see any other questions coming in right now. Guys, I can't thank you enough. It means a lot. Attendees, thank you for being here. Please look forward to our next webinar, which will be coming up June 28th. Your invites will be coming out in the next couple weeks. Daniel and Bob, thank you so much. Have a great afternoon, and I appreciate all the information you gave our attendees today. Thank you. Bye, everyone.
Bye-bye.